Now, if I have a rotation about a fixed body, in this case, I have to define what is called the angular velocity. And the angular velocity is in fact defined as the derivative of theta with respect to time. Now what is theta? Theta is the angular position of any point P. Because when a body rotates about a fixed axis, any point P will travel a circular path. So I should define its angular position by theta. The change of this theta will be called omega, which is the angular velocity. And of course, the change of this angular velocity should be called angular acceleration. Its symbol is alpha. And as we did for rectilinear motion, for the general motion of a particle, if I take dt here, then this dt will be equal to d theta over omega. If I replace d theta over omega here, and then omega will be in the numerator, then alpha, which is the angular acceleration, will be omega d omega over d theta. All right? So this is very similar to the general motion where a is equal to v dv over ds. And as the case of the general motion, when when the acceleration is equal to constant, this is also could be applied here by doing simple integration. So if the angular acceleration of the body is constant, alpha is equal to alpha constant, the equation for angular velocity and acceleration can be integrated to yield to this set of algebraic equations that could be used also in our problems. So I know, guys, that if a is constant, then v will be equal to at plus v0. So if you replace v by the angular velocity, which is omega, and a by the angular acceleration, which is alpha, you're going to have the same equations. So this is the equation of v, which is here the equation of omega. This is the equation of s, which is here the equation of theta, because theta is the angular position here. And this is the independent equation of time. If you remember, v squared is equal to v0 squared plus 2acv minus v0. So it's also applicable here for the rotational motion of a rigid body. And don't forget that theta 0 and omega 0 are the initial position and angular velocity respectively, and the third equation does not depend on time, which means I can have instead of 0, b or a or any other point. Now if I define p as the position vector, so r is equal to p, and then I do the derivative with respect to time for this r to find the velocity v, by applying, if you remember the cylindrical coordinates, you're going to have that VR will be equal to R dot and V theta will be equal to R theta dot. But I know that R dot is equal to what? It's equal to 0. All right? Even for rotational motion, R dot is equal to 0 because the magnitude of R is always constant. It's not constant in vector form, and that's why I'm going to have V theta. So it's not constant in direction, but it's constant in distance or in magnitude because this is a rigid body which is non-deformable, right? So VR will be equal to 0, and in this case, V will be equal to V theta, which is R theta dot. And remember, guys, that theta dot is R omega. All right, so it's only a matter of substitution. You can take all the equations that we know from the general motion and substitute v by omega in rotational motion for a rigid body and a by alpha, which is the angular acceleration. Now, guys, what I want you also to know is that if I have a rotation about a fixed axis, then v, the velocity, will be equal always, guys, to the cross product of the angular velocity with the vector of position. All right? So it's always perpendicular to omega and rp, and in magnitude, it's equal to the magnitude of cross product, which is omega rp times sine the angle between them. All right? So v is always equal to omega cross rp, all right? And of course, in the cross product, I can find the direction of v by applying the rule of right hand, right? So if this is r and omega is, for example, in this direction, the omega cross r will give me this v. So you have always to start by omega cross r, and you're gonna have the direction of v. Now, what is very important to know is that omega and r in the rotational motion, or they are always perpendicular, because as you know, this is omega. It's along the fixed axis. And this is r, it's the position of the particle or of the point on this rigid body that is rotating around this fixed axis, which means omega and r are always perpendicular. And as we know from the cross product, if I have two vectors that are perpendicular, then sine alpha will be equal to 1, and then in this case v will be in magnitude equal, so v in magnitude will be equal to the magnitude of omega times the magnitude of r. I'm gonna use this relation in this slide. So as I know, guys, from the equation of general motion, the normal acceleration stands for the change in the direction of velocity, while the tangential acceleration stands for the change in the magnitude of velocity. So if I go back and take the equation of v squared over rho, then and replace v by omega times r, then you're gonna have that a in n, which is the normal acceleration, will be equal to omega 2 times r. So it's only a matter of substitution. Now, if I take at, which is the tangential acceleration, and do the derivative of the velocity in magnitude or in algebraic form, dv over dt will be equal to the derivative of what? Of omega times r. But I know that r is not changing with respect to time, because in fact this is a rigid body, it's a non-deformable body, so that r is always constant in magnitude, which means I can remove this r from the derivative, and then I'm going to have only d omega over dt, which is alpha, and that's why at is equal to alpha times r. Now you can do this also from the very beginning by starting from the vector form. So I know that a in vector form is equal to dv over dt, and I know that v in vector form is equal to omega cross r. So I can do the derivative using the chain rule. It's d omega over dt cross r plus omega cross dr over dt. Now, I know that d omega over dt in vector form will be equal to alpha in vector form. So the first term will be alpha cross rp, which is in fact a tangential. But the second term is omega cross dr over dt. I cannot say that this is 0 now because it's in vector form. It's 0 if it is in magnitude, as we did previously, but since now it's in a vector form, I cannot say that dr over dt is equal to 0. So in fact, dr over dt is nothing but the velocity v in vector form, and I know that this velocity v is equal to omega cross rp, right? The position r. Now, if I substitute this by this equation, I'm gonna have that an will be equal to omega cross rp. Now, what is this one? What is this term? In fact, omega cross rp, I know that omega is perpendicular to rp, will be in magnitude omega times r. And omega cross this vector, I know that the cross product will give me a vector that is perpendicular to the plane formed by omega and r, which means if I want to do omega cross a vector that is perpendicular to omega and r, then this will also give me the magnitude, because omega will be perpendicular to this vector. So the cross product between them will be also the magnitude of the terms or of these vectors. So it's also times omega. So omega times r will be omega squared times r. Now, how to find the direction? In fact, I know that v, this is v, will be the vector omega cross r, all right, and v will be will follow the direction of the right hand rule, which means omega r will give me v, all right, so like ijk, and this means that if I want to find omega cross v, so omega cross v, now this will give me minus r, all right, So you can do it like this in a circle. Let's say omega cross r. So this is r will give you v. So let's say this is the positive direction. Omega cross r will give you v. Then I'm saying now I need to find omega cross v. So it's in the opposite direction. Then this will give you minus r. So that's why, guys, the direction of this vector will be in minus r and its magnitude will be omega squared r. Alright, so A will be equal to alpha cross r, which is the tangential acceleration, minus omega squared r, which is the normal acceleration. And of course, A in magnitude will be the radical of 80 squared plus AN squared. So far, we talked about the translational motion for a rigid body, and we found that the velocity for any point of this rigid body should be the same because, in fact, AB is always constant. It's always constant in magnitude since this is a rigid body, but it's also constant in vector form since this is a translational motion. And then we found that if I have a pure rotational motion, then V will be equal to omega cross R, and in this case, AB will not be constant in vector form, and I can have a normal and tangential acceleration. Now, what if I have a general plane motion? A general plane motion, as we said, is a combination of translational and rotational motion. So in order to do our analysis, I'm going to take A as the base of this rotation. So I'm going to assume that A is the base of this rotation, which means A belongs to the axis of rotation. And I'm going to use the relative motion analysis. So I know, in fact, that dRA, I know that RA is the position vector for point A, RB is the position vector for point B, and RB with respect to A is in fact AB. So it's the vector position B with respect to A. So I know, guys, that dRA will be the displacement of point A, and this will occur due to translation. dRB will be the displacement of point B, and this will also occur due to translation. But dRB with respect to A, the change of AB in direction will be, of course, because of the rotation of B with respect to A. So I'm going to start by the relative motion analysis, as I know dRB is equal to dRA plus dRB with respect to A, and then I'm going to do the derivative with respect to time, and now I know that RB with respect to A will never be constant here because I have a translational motion. So what is dRB with respect to dt? This is, of course, VB. What is dRA with respect to time? This is, of course, VA. And what is dRB with respect to A with respect to time, which is VB with respect to A? I know, guys, that VB with respect to A from the rotational motion, this should be equal to omega cross RB with respect to A, which means, guys, that the velocity at B should be equal to the velocity at A plus omega, which is the angular velocity with respect to fixed axis, cross RB with respect to A. So this will be the equation of what? This will be the equation of the combination of translation and rotation, which is called the general plane motion for a rigid body. Thank you.